Hello everyone, welcome to the 10th episode of this Deep Learning with Pytorch series. In this 10th episode, we will finally get started with Pytorch, and we will very much will do the groundwork which is related to the Pytorch basics, how we several topics needs which the topics which will be covered in this session is like PyTorch installation, then creating a PyTorch tensor. Once you create a PyTorch tensor, how we can convert it to a NumPy array, and also the vice versa of it, that is converting a NumPy to PyTorch tensor. Then resizing of PyTorch tensor. What are the functionalities that are available in PyTorch to do the resizing of PyTorch tensor? Then this very important thing which is related to PyTorch is Autograd function, right? How the PyTorch calculates the gradient of or the derivatives of different function, right? So we will take an example and we will try to go deep into that using PyTorch and how the gradients are kind of getting calculated on top of that, right? Then we will try to understand how the dot product and matrix multiplication works in PyTorch with the help of by building a simple feed forward network, right? And then in the end, we will talk about how the PyTorch broadcasting works, right? Okay, now let's get started. To do the PyTorch installation, what you can do is you can visit this link. So the link to this notebook I will give in the description of this video. So from that you will get this link, and once you open this link, you can select the configurations according to your need, right? Based on like PyTorch build, and based on your OS, or if you want to do a Conda installation or a pip installation, and based on the language, like if we are selecting Python, and also based on the compute platform, right? So if you do not have GPU, you can still install PyTorch. So for that, you need to select CPU here, and based on that, it will generate a command. So I have given the command here also. So this is the command you need to run. Um, Inside your notebook, or you can run from the command prompt. So while running from the command prompt, you don't need to give this exclamation mark. Otherwise, if you're running in the notebook itself, you can run it straight away using a code block, right? So like these things will be installed, like PyTorch, the Torch Vision, which are related to computer vision, and Torch Audio, which are like newly released thing for PyTorch, which generally works well with the audio data, right? So similarly, if you have like GPU, right? Say for an example, like if you are running PyTorch code in Colab or Kaggle, or in your own machine where you have the GPU access, right? So then you can select this CUDA version, and you will get this command which you need to run. Now, the good thing for Colab or Kaggle is if you're running your code in Colab or Kaggle, PyTorch is already installed there. So you don't need to do any installation, and you can straight away start writing code on PyTorch, right? Okay, so this is the command to do the GPU version installation. Okay, now let's first create some tensors using PyTorch, right? So this is one of the type of PyTorch tensor which I am creating, and I am naming it as T. So the shape of this tensor is 2, 3. So there are 2 rows and 3 columns, right? And the number of dimension which is associated with this tensor is 2, right? Now, as we have seen, like we need to do transpose in several cases, right? If you need to match the dimension while doing the dot product or matrix multiplication, we need to do the transpose of it, right? So this is the way to do the transpose in PyTorch. Now, similarly, you can create a PyTorch tensor of zeros, right? So this is like you will create a PyTorch tensor of zeros with 3 rows and 3 columns, right? Um, so this is how the output looks like. Now, so this very beautiful thing which is also available in PyTorch is you can convert your NumPy arrays to PyTorch tensor, and also if you get the output of your PyTorch model in PyTorch tensor type, then you can convert it back to NumPy array to do like downward operations, or the further operations on top of that, right? So this is where I am creating a NumPy array, and then I can convert using this function, right? Torch dot from NumPy, and then mention the NumPy um, array name, and we will get the NumPy array converted to Pytorch tensor, right? So if I just print this t, so this t you will see it is kind of a tensor, right? And the data type is torch dot float 64. And if I just take the type of n, it is a NumPy array. And if I check the type of t, it is a torch dot tensor type, right? So these are the things which you should be aware of, like how you can convert NumPy array to a PyTorch tensor, because whenever you will building a neural network, your data needs to be in PyTorch format or in the torch data type. Otherwise, you will not be able to fit that data to the model. So you need to convert your NumPy array or pandas array to a torch tensor, right? And let's check the shape of this. So the shape of this is 1 comma 2, and we can similarly convert torch tensor to numpy, right? So you just need to call this dot numpy function, and it will convert the torch tensor to numpy, right? So this is how the output looks like. You will see once I done the conversion, I'm creating a new numpy array which is n1, and the type of this is numpy dot nd array, right? Okay, now let's talk about resizing, how we can do the resizing of a torch tensor, right? So at first I'm creating a 2 by 2 torch tensor with random numbers, and this is how the output looks like. Now if I just check the shape and dimension of this torch tensor, so it tells you like there are 2 rows and 2 columns, and the number of dimension in this torch tensor is 2, right? Now if I want to do the resizing, right? Say for an example, we want to convert it to a one-dimensional array with 4 elements, right? To do that, what you need to do is you need to call this dot view method, and you need to pass the number of elements or the dimensions on which you want to convert or resize your torch tensor, right? So if you see here, it's kind of a flattened array where we have 4 elements, and if you just check the shape and dimension of this, the shape of this array is 4, only 4, because it's kind of a 1D array. You can see like the number of dimension is 1, right? Using this command, you can check the dimension of this array. So similarly, you can convert or reshape this array with this -1 comma 2, right? So what it internally does, it will create a torch tensor with 2 columns, and this dimension will be automatically inferred, right? So the number of rows will be calculated automatically by PyTorch, right? So if I just check this, you'll see like 2 number of rows are created, and along with 2 number of columns, right? So if you write down -1 when you are not sure about that dimension, particular dimension of particular axis, you can write -1 so that PyTorch can, with its own intelligence, can convert that to a specific dimension, right? Now, if I just check the shape of this, so it's a 2 by 2 array, and the number of dimensions are 2 here, right? Okay, now let's talk about this Autograd, right? So this is the core functionality of PyTorch, by which it's calculating the gradients, and it's doing like the back propagation where we generally calculate the model parameters derivative, right? We calculate the derivative of loss with respect to the model parameters, right? So this is where the beauty comes in. So if you have seen my last videos where I have done the implementation of linear regression and logistic regression from scratch, there I need to derive the equation for linear regression and logistic regressions derivatives, which are like dw and db, then use those in the gradient descent optimization phase. Using those equations, I was doing the uh, optimization, right? But if you wrap your tensor with this requires grad equals to true, so it will remember where it will remember the operations that you are doing on top of that particular torch tensor, and it will, when you call this backward method, right? So this dot backward method will kind of will calculate the gradient with respect to the particular variable, right? So this is the thing which you see, that is kind of an old version of PyTorch. So if you are using an old version of PyTorch, you need to create your variable in this way. But you, with the new version of PyTorch, you can just create this torch tensor and mention the requires grad equals to true, and it will kind of it will remember the operations you are doing on top of this tensor. And when you will do when you will call the dot backward method, it will kind of calculate the gradients based on the operations you have already done on that torch tensor, right? So what I am doing is, I am just at first I am taking a power of each of the elements to the power of 3, and then I am doing a torch dot sum, right? So this Autograd function works only on top of a scalar value, right? So you need to do you need to convert your tensor to a scalar operation or a scalar value, then you can call this dot backward method, right? So what this is happening is, each of the numbers are raised to the power of 3, then we are taking a sum, right? So this is how it is working, and you will see the end output is 100, right? So you will see like grad function is equals to sum backward, right? So with this method, it will remember that we need to, like, the operation that has been done on top of this is kind of a sum, right? After raising the each of the elements to the power of 3, right? So when you calculate, when you call this y dot backward, it will compute the gradient with respect to a, right? And then you can access the gradient values using this a dot grad dot data, right? So if you see, like, these are the values which are coming as output of, after taking the after calling the dot backward method, right? Which is kind of the operations which you see. This I have written down the operations here. Now let's try to understand this. First, I create a tensor where each of the values are like 1, 2, 3, 4. Then I am calling this function, right? Or calling this operation, which is like torch dot sum, and I am raising each of the elements to the power of 3. So the in between this, these are the operations which are going on, right? One is raised to the power of 3, and all the elements of this tensor is raised to the power of 3. Then we are taking a sum out of this, and we are getting the output as 100. Now once I call this y dot backward, right, what it will do is, it will remember that each of the elements were raised to the power of 3. Now using the formula of derivative, which is like derivative of x to the power n is nothing but n into x to the power n minus 1, right? So this 3 will come out as n. So this 3 is nothing but n. So that n will come here, and 1 to the power 2, right? 3 minus 1 is equals to 2. Similarly, for this element, like n is 3, so 3 will come out here, and 2 to the power 2 will be calculated in this element wise operation for each of this element of this PyTorch array, right? Then you will finally get the output as 3, 12, 27, 48, right? So this is the output which I am also getting here. So the element wise derivatives are calculated, and then the output is then PyTorch is giving you the output, right? So this is, I hope this is clear to you. So this is the core, or the one of the very beautiful thing which is available in PyTorch, how the autograd function works. So I hope you understand with this simple example. Okay, now let's try to understand how the dot product and matrix multiplication works in case of PyTorch by creating a feed forward network, right? So feed forward network, if you remember, what we are doing is we are kind of multiplying each of the elements of my input feature with the corresponding weight, and then we are adding the bias to that, right? So let's set a seed to this. So this will kind of allow us to reproduce the result, right? So if you are doing any experimentation on PyTorch, so this is kind of, if you want to reproduce that, you need to seed, you need to set the seed for a particular value. Then you can reproduce that thing, like the output will be always same, right? No, at first I'm creating a 2 by 5 input, which is nothing but X. Then I am creating a weight tensor, which is where we are initializing those values with random values. And I'm asking with this function like rand like, I'm asking you just create the dimensions same as X, right? So the weights with the same dimensions as features that we are creating in this operation, right? Then we are creating a bias, which is like a 1 by 1. And after that, I'm just creating activation function, which is nothing but a sigmoid activation function. Now let's check the shape of W, right? So the shape of W is 2 comma 5, right? And my shape of X is, if I just check the shape of X, so it is also 2 comma 5, right? Now, if you want to do a dot product of this, we need to change my shape of W, right? Either we need to make it 5 comma 2, right? If you want to do a dot product between my X with W, right? So to change the shape of my W, there are two ways. One you can do is you can call this dot view method and pass your required dimensions on this function of view, and then you check the shape of this. You will get the output as 5 comma 2, or you can just transpose the weight vector, right? Or sorry, the weight matrix, and you will get the output like this. So in every for each of these operations, your shape is 5 comma 2, right? Now you can do the dot product, right? Now let's try to do this dot product, right? So it's throwing an error for you. So this error is, it's telling you that it's throwing a runtime error. 1D tensors expected, but got 2D and 2D tensors, right? So all this, which are like X, W, these two things are 2D tensors, right? So this you need to remember, right? So you can just go to this document, which is like the document associated with Pytorch dot product. So if you go to this document, you will see like unlike NumPy's dot product, Pytorch's dot product is only compatible for 1D array. So if you want to do a dot product between a 2D array or a matrix, you cannot use a torch dot function on top of a 2D or multiple dimensional array. So this dot product only works with uh, 1D array, right? So this is where I am creating a 1D array and I am doing a dot product. So this is working fine, right? Now let's see how we can do the matrix multiplication, right? If you are not able to do it using a torch dot, what we need to use? So we can use this torch dot which is like a matrix multiplication short form, and then you can do at first we will do the dot product between this is kind of the dot product between the my input variable and the W or the weight, and then we will add the bias to that and we will get the Z, which is nothing but the linear part, right? And then we pass this linear prediction through the sigmoid activation layer to get the final output, right? So this is how the final output looks like, right? So you need to remember this. If your tensors are multidimensional, like which is greater than 1, then you have to use this torch.mm. Your torch dot function will not work if you are working with 2D tensors or 3D tensors, right? Now let's understand another basic concept of PyTorch, which is like PyTorch broadcasting, right? So for an example, we have like this array, right, which is kind of a 2D array or 2D torch tensor, and we want to add a 1D array with these values, right? So the operation which I am doing here is like this is a tensor which I am creating. I'm also creating another tensor, which is kind of a 1D tensor, and then I am just trying to add these two. So this will give me the result, right? And in the back of this, what PyTorch is doing is it creating a copy of this array, and it is kind of replicating in this way, right? And then it's doing a element wise sum, right? So for the second row, it will replicate the values with its own intelligence, and then it will do the element wise sum. So this 1.1 will be summed with 5.4. Similarly, the other things for this row, and this 1.2 will be summed with 5.4. With the help of this PyTorch broadcasting, which we don't need to do it in our code, the PyTorch by its own intelligence, it will kind of create a copy of your first row, and it will create a 2D array out of it, 2D tensor out of it, and then it will do the sum between your A and B, right? So yeah, that's all I wanted to talk in this video. I hope you like this video. So yeah, in the next video, we will try to do a PyTorch implementation for a complete neural network using certain functionalities which are available in PyTorch. Yeah, thanks for your time. I hope you like this video. Thank you again.